Welcome to the lesson 22 of the Advent of SysML v2. This training series is brought to you by Sensmetry in collaboration with Vince Molnár. My name is Kestutis, and in this final week we are focusing on requirements. They enable defining what systems must do before we decide how they are designed. By the end of the lesson, you will know how to model requirements and how to specialize and decompose them. Think of requirements like the rules of a game. Before anyone starts playing or designing anything, everyone agrees on what winning looks like. Requirements are that agreement between the stakeholders and engineers. They define success criteria before design begins. In SysML v2, requirements are first-class modeling elements, fully integrated with the rest of the language. This is major departure from SysML v1, where requirements were essentially decorated text boxes. In v2, requirements can have typed parameters, specialize each other, and be composed hierarchically. To model SysML v2 requirements, we use already familiar definition and usage pattern with keywords requirement def and requirement. At minimum, a requirement needs to have three things: an identifier, a name, and a shell statement. Let's look at our first requirement definition. Line 6 declares a requirement deliver gifts using keyword requirement def. The short name in angle brackets UR1 serves as the requirement's identifier. The declared name deliver gifts is the requirement's name, and the document on lines 8 and 9 captures the shell statement. Now notice line 7, the subject declaration. It references the Santa sleigh from our specification package. This is the subject parameter. It declares what the requirement is about. By typing the subject with a part definition, we immediately establish a link between our requirement and our design. But here is what's important to understand. The subject does not mean part satisfies the requirement. It only declares that this shell statement is about this element. Satisfaction is a separate relationship. We'll explore that in a future lesson. Once we have high-level requirements in the problem space, we move to the solution space. We decompose our system into subsystems, and our requirements need to follow. High-level requirements become specific ones tied to each subsystem. In SysML v1, the typical approach was the derive requirement relationship. But in SysML v2, we have something better: requirement specialization. What is the difference? The derive requirement relationship was just a traceability link, no formal semantics. Specialization gives us real semantics. If the specialized requirement is satisfied, the general one is guaranteed to be satisfied too. Here's why that works. Think of the requirement as a logical statement with parameters. When you instantiate it and fix those parameters to specific values, the statement becomes either true or false. A specialized requirement constrains those parameters. It narrows the set of valid instances. So if all narrower cases pass, the broader requirement is automatically covered. Let's see requirement specializations in action. First, look at our design model. On lines 13 through 17, we have specialized a Santa sleigh's part definition with a cockpit, cargo bay, and Santa. Now look at line 31. We declare a new requirement TR1 deliver gifts that specializes the original UR1 deliver gifts requirement. Line 32 shows the key pattern. Subject redefines sleigh, defined by Santa sleigh definition. We are redefining the subject to be the design version of Santa sleigh, not the specification version. The result? This requirement now applies to sleighs with cockpits and cargo bays, our concrete design, not the abstract specification. Now you can refine your requirements in step with your system design. As your design becomes more concrete, the requirements become more concrete too. This is refinement-based modeling, and specialization makes it work beautifully. The other thing that we typically do when refining requirements is decompose them. a complex requirement becomes several simpler ones, or we map a system requirement to subsystem requirements. In SysML v2, these sub-requirements are modeled as nested usages inside the parent requirement. This is significant improvement over version 1 of SysML, where containment was mostly a graphical convenience. Let's look at how this works. Inside our specialized deliver gifts requirement, we add two sub-requirements. On line 34, we have an unnamed requirement usage. It's just the requirement keyword followed by the type. No name needed since we won't reference it elsewhere. Lines 35 through 38 show another unnamed requirement usage. This time it has a body. Here we manually set a subject to be the sleigh's cargo bay. The requirement definitions themselves are on lines 41 through 49. Cockpit for Santa has the sleigh as its subject, same as the parent. Cargo capacity has the cargo bay as its subject, a subsystem of the sleigh. This is the key pattern for subject binding. If you don't specify a subject for a sub-requirement, it inherits the parent's subject. But if you do specify one, you can point it at a specific subsystem. So when we evaluate deliver gifts on a concrete sleigh, Cockpit for Santa is evaluated on the same sleigh, default binding. Cargo capacity is evaluated on that sleigh's cargo bay, manual binding. This gives us two use cases with one mechanism. You can decompose a complex requirement into simpler ones on the same subject, or you can map a system requirement to subsystem requirements on different subjects. To conclude, requirements in SysML v2 are fully integrated model elements you can specialize and decompose, keeping them in sync with design as both evolve. Your challenge for today is to add stealth mode requirements to Santa Sleigh, a high-level requirement and a specialized version with sub-requirements. Check the blog post for details. Share your experiences and ask questions in our community forum. Links and information on Syside Cloud Access is available in video description. Like the video, subscribe to our YouTube channel, and click on the bell icon to get notified about future lessons. Take care and happy modeling!